Our next assignment is to make a recursive add method. And based on its specification, we're taking in two integers, x and y. And the base case here is if y is 0, then adding 0 to x simply returns x. Let's identify this as our base case. Otherwise, we want to return add of x plus 1, y minus 1. And it seems like a fairly good specification for this, and we need to write some testing code to see if it works. So let's try a new JUnit test case. And I could do some simple tests. Let's try some things like 0 should be, save this so we can see it over here. 0 should be, forgot the word static. Okay, now there's add. So if I add, say, 0 and 0 together, that should give me 0. Let's see if that works. Sure, that's fine. How about testing a bunch of zeros? So let's try I is 0, I is less than 10, plus plus I, and let's assert equals that I should be the add of 0 and I. As it should also be what I get by adding I and 0. So it shouldn't matter which order that I add those two in. Those should both work out the same way. We get the green light. Let's try some more aggressive. I'm going to write a second test. Public void, I'll call it test 2. And I'm going to do I goes to 0, I is less than 100. I'll try all the integers from 1 to 100. And let's try another loop. How about j is 100, j is less than 200. We'll add j. So I and j are taking on different values, but I can still assert what their sum should be, because Java will compute that for me automatically with a plus in between. And that should be the same thing as I get by calling add.add, passing I and j. Okay, so I'm going to try a bunch of different sums there. Now if I run this, actually let me put a bug in here. I'm going to incorrectly specify the sum should be I plus j plus 1. I'm going to rerun the test, and it looks like it passed, but if I look at more detail here, it only ran test and not test2, and the reason for that is you must put a test directive before the method. So I was missing this. And once I put that there, we see that test passed, but test2 did not pass. It was expecting 101 but got 100, and that's not surprising because I have this mistake here in the test. So let's put that back the way it should go and run the complete test. And we see on expansion both test and test2 ran, 2 out of 2 tests run correctly, and so our code is working well. Let's look at the conditions under which this add method is going to work correctly. I want to be able to look at both of these at the same time, so I'm going to try to rearrange my windows a little bit here and get add and add test next to each other. And what I see is that over here for add, this only works correctly in the case where y, so we require that y is greater than or equal to 0. In fact, let's try a test which we don't expect to work. And let's try adding, how about negative 2 is the answer I get by calling add.add of 2 and minus 4. So that should be the correct answer. Negative 2 is 2 plus negative 4. But if I run this test, what happens is the stack overflows. The reason for that is that our add method over here, if y is 0, does the correct thing, but otherwise it keeps trying smaller and smaller values of y, but y is already negative. So going from negative 4 to negative 5 to negative 6, it goes on forever, and we run out of stack space, and so that doesn't work. Now, it would have worked had I reversed these two. So if I try it this way, let's see if that works. And that's fine because y is positive, or 0. In this case it's positive, and so we get negative 4 becomes negative 3, becomes negative 2, and then the recursion ends, and so we get the correct answer that way. So the question is, how do we fix this so that it works always? And what I'm going to do is I'm going to rename this method to be add helper. Because it's only going to work when y is greater than or equal to 0. I'll make a new method, and this is going to work all the time. Okay, so we know the problem happens if y is negative. So we're going to have to do something here. For now, I'm just going to return 0. But otherwise, we know we can return whatever add helper says to do with x and y. Okay, so what do we do if y is less than 0? Well, there's really two cases. Let's suppose that x is also negative. So if x is less than 0, then they're both negative, and I can compute their sum by computing add helper of minus x, which is now positive, minus y, which is now positive, and simply negating the answer when it comes back. So I'm going to count on add helper to work on the two positive numbers x and y. When I negate x and negate y, if they're both negative to come in, then add helper is going to see them as positive. And I'll take the result and negate that. So for example, if I add negative 4 and negative 2, I'm going to actually call it add helper with 4 and 2, giving me 6. I'll negate the answer on the way back and return negative 6, which is correct. Otherwise, x must be greater than or equal to 0. And what I can do, let's put that in a comment, is just swap them. I can return add helper of y and x. Because now the second argument to add helper must be at least 0, and it's going to work no matter what y is. So to see that this works, let's also try the original one that didn't work, add of 2 and minus 4. We should no longer see the infinite recursion. But I have to specify the right value here. That's my mistake, so let's fix that. Try it again. And it works. Now let's try a bunch of negative numbers. Maybe the easiest thing to do would be to start up here at negative 100, and maybe start here also at negative 100. Now we're going to try all kinds of additions, positive and negative, and we see that they all passed. So by changing add, the old method add, into add helper, which works only under restricted cases, I can now make add the public method that everybody calls, and it straightens out the call to add helper so that add helper always works and fixes up the answer on the way back if it's necessary. And once I do that, this method really ought to become private because it's not going to be used by anybody outside of add.